It's been a little more than 1 year after the Apple Silicon M1 hit the market back in November 2020. Personally, I acquired my MacBook Air, the base model with 8GB of RAM, 256GB of storage, and the 7-core GPU in early February of 2021, so I've been using it for about an entire year by now. Before getting this Mac, I had only ever used Windows or Linux on x86 hardware no less, with the exception of my previous laptop, which was a hand-me-down 2009 MacBook Pro with a Core 2 Duo. I am a self-proclaimed huge nerd, and I've been toying around with virtualization and emulation since my age was a single digit and my computer looked like this, and the specs on it looked like this. Yeah. Hence, one of the main concerns, or rather curiosities I had when entering this Apple Silicon ecosystem was how well it could handle virtualization and or emulation. Seeing as it was a brand new ARM-based platform with zero development on it aside from iOS projects, and you cannot tamper with the bootloader or natively install other ARM operating systems on it as of right now, I had my doubts about its capabilities in this sector, and I was ready to have a computer which was only capable of running Mac OS in the worst case. But thankfully, I was wrong. Oh, so wrong. I'm Chris Carlos, I like computers, and today I'll be looking over the state of virtualization on the Apple Silicon M1 platform a year after its release. Before I start, I would like to preface this by saying that everything I say in this video does also apply to M1 Pro and M1 Max, as those sadly also suffer from the same limitations as the regular M1, simply because they're based on the exact same underlying architecture, just with different core counts and GPU specifications. This limitation is the lack of nested virtualization, meaning you cannot run a virtual machine inside another virtual machine on M1. This is a hardware limitation and cannot be fixed with software. Also, I will not be focusing on gaming or Docker in this video, but rather just general full operating system virtualization, as I think both gaming and Docker on M1 are well documented in other sources. Lastly, I'm not sponsored in any way by any of the companies mentioned in this video. I mean, I literally have 0 subscribers as of uploading this, so I don't think they'd want to sponsor me anyway. There are currently a few ways to run virtualization or emulation on M1 machines. Firstly, let's look at free and open source methods. If you don't know anything about the M1 but you've used virtual machines on other computers, your first guess would probably be VirtualBox, as this is the most popular software to run VMs, and it's free and open source. Sadly, despite VirtualBox obviously supporting macOS, it doesn't support the M1 architecture, and Oracle has no plans of doing so, as their entire codebase is centered around the x86-64 architecture and they don't seem to have any intention of supporting ARM. On the free but not open source alternatives list, VMware Fusion Player, coming from the well-known virtualization software company VMware, does have a technical preview of their software built for M1, which I will check out later in this video. Currently, there is another free and open source software project that comes to the rescue for M1 Max, and it's called UTM. It's an app built from the ground up to be native to M1, as it was originally an iOS app that had to be sideloaded because of Apple's somewhat ridiculous security measures. Essentially, UTM is a wrapper for QEMU, a free and open source emulator and virtualizer for pretty much any architecture and system under the sun. You can also run QEMU via the terminal in all its technical glory, and if you know what you're doing, you can technically create virtual machines through QEMU without UTM at all. But in my experience, QEMU through the terminal is quite difficult to understand, so for the sake of this video, I'll be using UTM. UTM is a beautiful graphical application that looks right at home on macOS Monterey, and it enables you to create virtual machines for pretty much anything you want, regardless of architecture. I will touch on this a bit later, but for now let's focus on ARM64 virtualization. On UTM, you simply press the little plus icon on the top of the window, select the architecture of the virtual machine, import your disk image file to boot from, create a virtual hard drive, and boom, you're in business. Hopefully you won't have to touch any of the other settings. They are a bit daunting, and it'll probably take some trial and error to get them right if you don't know exactly what you're doing, if you even have to modify anything in the first place. UTM also provides a library of virtual machines to choose from, pre-built VM configurations that you can download and run as is from their website to save you from some of the hassle of having to set them up yourself, which is refreshing to see. Very user-friendly. I won't even try to install Windows through UTM in this video, it's too much of a hassle. You're way better off just downloading one of the pre-built Windows VMs and customizing it afterwards. There are drawbacks to UTM, and they come from the limitations of QEMU on M1. Namely, despite being compiled natively for ARM, QEMU and UTM by extension cannot take full advantage of the M1 architecture just yet, and it's unsure if they ever will. QEMU cannot access the macOS hypervisor, meaning it cannot talk directly to the host OS, which is essential for achieving maximum performance. This becomes very evident when you try to run anything that uses GPU acceleration through a UTM virtual machine. While GPU acceleration is supported, and it's pretty okay, it's not as fast as it could be, as it cannot take full advantage of the integrated GPU. This leads to subpar graphical performance, with lag and glitches at times, but it's overall not that bad. In a previous version of this video's script, I was way harsher on UTM's lack of full GPU support, but something changed my mind, and you'll see what I mean later. As you can currently see, I'm testing various things on this Alpine Linux virtual machine to see how it stacks up to my already existing Alpine Linux virtual machine that I created with another solution. And I have to say, I'm not too impressed from the performance. However, all things considered, for a free and open source application, UTM does a fantastic job of providing an adequate virtualization experience on M1 Mac computers, and the performance you're seeing here is actually worse than it is in practice because Apple's screen recording solution is slowing things down a bit. In reality, it's smoother than it is on video. Just a little bit. There is another feature of UTM that's worth mentioning, and this is emulation. Previously, when I was setting up my VM, you saw that I had to choose the architecture of the guest system, and that it actually defaulted to x86-64. This is because UTM was originally designed as an emulator for x86 systems on iOS. Essentially, virtualization requires that the operating system you're virtualizing is built for the exact same architecture as your host operating system. If they don't match, it's not virtualization, but rather emulation, if it even works at all. Since UTM is a wrapper for QEMU, and QEMU can emulate any platform you throw at it as its name suggests, UTM can emulate x86 operating systems too. I ran Windows XP on it back when I first got my hands on my M1 machine just for fun, to see how it would run. Spoiler, it was quite slow. This is because emulation is an extremely more CPU intensive task than virtualization, and at the same time, emulation on M1 is not optimized whatsoever, or at least it wasn't when I tried it. Don't get me wrong, it worked better than I expected in fact, but it was not usable by any means. The speed at which the emulation ran was nowhere near the speed the average user could accept as a usable system. Still, it is a cool novelty and something only UTM can achieve. Moving on from our lovely free and open source software, if you want something more functional yet less customizable somehow, Parallels Desktop might be the solution you're looking for. While it's not particularly cheap and I don't quite like Parallels' pricing model, in the end I did end up buying a Parallels Desktop license to run smooth Windows and Linux virtual machines on my M1 Mac. Yes, UTM exists, and yes, UTM is far better than I expected, but it has these little bugs and quirks and little things that just take away from its reliability, especially when you're trying to run Windows on it. It's evident that it's a passion project and not a commercial product. If you're looking for virtualization software to run Windows VMs on M1, look no further than Parallels Desktop. While it cannot do emulation, that's not what it's designed for, and that's not what we're looking at here. As I hinted at earlier, Parallels Desktop is the most effective way to run virtual machines on your M1 Mac, and it's also very easy to set up, way easier than UTM, that's for sure. It's built with Windows VMs in mind, and it even tries to integrate Windows apps into macOS if you really want it to, with the goal of creating a more seamless experience. Against Microsoft's frankly ridiculous restrictions against virtual machines, Parallels has a built-in virtual TPM chip to flawlessly run Windows 11. You will have to go through some hoops to download a Windows 11 image that's built for ARM, but once you get your hands on one or you update from a Windows 10 on ARM version, you should expect near-native performance with unparalleled, pun intended, smoothness. With the basic license, Parallels will let you allocate up to 4 CPU cores to your VM, which is more than enough for a base model M1 machine, but if you're on an M1 Pro or M1 Max Mac, that's a mouthful, you might want to shell out a few more bucks to get a license that gives you more power over your VMs. Let's face it, if you have one of those computers, you surely have around 90 bucks to spare for software. Again, I really dislike this kind of pricing model, but it is what it is, and for what it's worth, the product is really impressive. This is, as far as I know, the best alternative to the currently unsupported Apple Boot Camp that allowed you to install Windows or any other OS natively on Macs in the past. Up next on the list of contestants is VMware Fusion Player. VMware's marketing for this thing is very confusing, so I haven't even seen many videos talking about it as an option. At first I thought it was a competitor to Crossover, but VMware Fusion Player is a free for personal use virtualization software solution for macOS. As of the making of this video, there's a technical preview version of Fusion Player 12 available for M1, and I downloaded it to test it. Well, originally I accidentally downloaded the Intel version of it because for some reason the technical preview is hidden from the website, but one uninstall and reinstall later, I had VMware Fusion Player 12 up and running. Fusion Player has a feature that allows you to import virtual machines from other computers, or even other virtualization software on the same computer, seeing as most virtualization software uses the same or similar standards, but in my experience I could not get this feature to work. This is a trend with VMware Fusion Player as of right now. I can't get many things to work. I can't get much of anything to work, to be honest. What I do like about Fusion Player as a competitor to Parallels Desktop is that Fusion allows you to allocate as many CPU cores as you want and as much memory as you want to your virtual machine without paying a single dollar. It generally gives you more control over your virtual machines. If only they worked. That being said, I'm really not impressed by the M1 technical preview build of this software. I can understand why it's taking VMware so long to release another version, as the bugs in this one are so numerous that it's hard to even recommend as an alternative. Firstly, in my usual Alpine Linux virtual machine, GPU acceleration was simply not supported. This option is grayed out, and while it says that with an appropriate Linux kernel it's possible, I have not been able to find a single distribution that supports this. After installation, VMware did not boot into the virtual hard drive by default, despite the settings of the virtual machine telling it to do so. I had to disconnect the virtual CD/DVD drive for it to finally boot from the virtual hard drive. Upon installing the graphical user interface, I was faced with the cold hard truth about VMware Fusion Player right now. It's worse than UTM. In fact, UTM feels great in comparison. This is what made me realize I was being too harsh when talking about UTM's lack of graphics support in an earlier version of this video's script, because I experienced the absolute terror that is attempting to create a usable virtual machine within VMware Fusion Player on M1. Animations were non-existent, tasks were slow, the resolution was stuck at 1024 by 768 with no option to increase or even decrease it, and this godforsaken window keeps resizing itself every single time a new graphical backend is loaded, despite me clearly sizing it to my liking earlier. I thought, okay, maybe Linux isn't Fusion's forte, maybe I should try Windows. Wrong, VMware Fusion Player on M1 doesn't even support Windows officially. Despite there being guides out there on how to actually install Windows on it, I've been unsuccessful in both of my attempts, receiving an error that I couldn't be bothered to fix, as it became clear that this software was simply not made for this. As a last-ditch effort to find any redeeming qualities in VMware Fusion Player, I downloaded a Fedora Linux image to see if graphics would be supported on it. After all, it is one of the officially supported Linux distributions of this software, as is evident when you try to select which distribution you're installing. It pops up right there. Just when I thought I couldn't be more disappointed by Fusion Player's performance, or lack thereof, Fedora Linux straight up refused to boot. Or rather, it froze as soon as it had to display any graphics. I tried clicking on things, I tried keyboard shortcuts, nothing worked. When I sent the shutdown signal, it shut down just fine, so the OS itself was not frozen, just the graphics. If I had to guess, it has something to do with X11 or Wayland or both, but again, I just can't be bothered to try to troubleshoot this. If I have to troubleshoot such basic things, it's just not worth it. UTM handled everything flawlessly in comparison. For a high-profile, popular player in the virtualization industry, VMware really dropped the ball on their M1 support. I know that this is not a final product, and I do acknowledge that whatever I'm reviewing right now is beta or even alpha software, but it's been over a year since the release of M1 by now, and I would expect VMware to have made some progress like Parallels did. I would not recommend VMware Fusion Player 12. Yikes. Overall, virtualization on M1 feels like it's still in its infancy, or at least it feels like we've hit a standstill when it comes to independent development. While the free and open source software community is trying its hardest to create definitive solutions for new problems arising from a new platform, proprietary software with the support of Apple has largely surpassed those efforts. While it's great as a starting point, it simply doesn't make sense to keep using UTM on M1 if you're serious about virtualization. And sadly, there is no open source alternative that can take full advantage of the macOS hypervisor as well as Parallels can. While UTM is fun to toy around with, if you mean business, Parallels Desktop is the only solution that makes sense both when it comes to performance and ease of use. And unfortunately, it's uncontested. There is no competition when it comes to virtualization on M1, as VMware's showing has been disappointing at best and absolutely unusable at worst. I really hope that in the future we have some compelling solutions that don't cost an arm and a leg. For what it's worth though, Parallels is quite excellent right now and only gets better with each update. I do hope we see some competition in the future, but I'm glad Parallels was there to provide a virtualization solution for M1 from the very beginning, and that they're working hard to optimize the Windows performance of Parallels Desktop as much as possible, completely ignoring Microsoft's ridiculous restrictions against ARM virtual machines, probably due to their presumed deal with Qualcomm. On the one hand, it really sucks because on Windows or especially on Linux, you really have very little reason to purchase proprietary virtualization software to run smooth VMs. I've gone a whole decade virtualizing various OSs with free and open source software on my other machines. Yet now, on my most powerful device yet, I have to pay hefty sums of money to have a smooth virtualization experience. On the other hand though, just a single year after the release of this brand new platform, we have near native performance in pretty much any ARM64 OS through Parallels Desktop. If you enjoyed this video, I would appreciate it if you could support the channel in some way. Leaving likes helps a lot with the algorithm, and so does subscribing if you'd like to see more content like this. Until next time.